Center of mass today, a very important and fundamental concept in rigid body mechanics. Consider this rod, initially in horizontal status, and there is a support not at the center. If I release this rod, the effect of gravity will make a rotational acceleration on that. So it will have a torque on the object and it will have a clockwise rotation. How to avoid that? How to hold the balance? The only chance is using just a single support is putting the support at the center. Here at the center, we have a point which is called center of mass. When it's exposed to gravity, also it's center of gravity, at which we can draw the downward force of W, and we can consider all the mass of the object has been concentrated there. Why there is no chance of any rotational acceleration, any angular acceleration of W? The reason. On top here, we have a W acting on the center of mass, but here it's separated for a distance d to the center of rotation. Okay, so there is a torque. Torque is force times distance. This is why it starts a clockwise rotation. But the bottom case doesn't have any torque because there is no d. D is the separation between the W, the point at which the W is acting, and the point at which the support is holding the rod, center of rotation. There is no torque due to gravity on that object. So it's another property of center of mass. How to define the center of mass? The center of mass of an object is the point at which its mass can be thought of as being concentrated there. The behavior of object is like that. We can draw the weight vector from center of mass always. If the center of mass is here, you can always draw the downward force of W exactly starting from that point. Yes, we can. And moreover, again, another emphasis. If the object even has a very irregular shape, if the center of mass is here, and if you support it from exactly beneath that point, W is drawn like this. And center of rotation and center of gravity are coincident. Chance of rotation is 0. So there is no rotational acceleration because there is no torque due to gravity. You can also hang the object from that point, not necessarily with a support from beneath it. No, it could be even hanging point. You remember in projectile motion, I told you if I throw an object in a space, a point mass, it will travel on a parabola. What if the object is not a point mass? Same, center of mass will travel on a parabola. Not all the points of the object, no, because it may have rotation and some points may have a very complicated path. But center of mass, always on a parabola. It's another very interesting aspect of center of mass. Suspended equilibrium. Here I have an object hung from this point. I have two critical points, center of gravity, center of mass, and hanging point. Here I can draw the W, downward W, and then I extend the W, and this is the line of action of that force. There is a distance between this line, dashed line, and the hanging point. So we have torque, which is W times D. This torque will rotate the object and takes it to the suspended equilibrium. In this situation, here I have the hanging point, center of mass, and the center of Earth set on a line. And there is no torque of gravity anymore. There is a message behind that. The object is in suspended equilibrium when the hanging point, center of mass, and the center of the Earth are set on a line. So if I hang a very irregular shape from every arbitrary point, I can 100% make sure that center of mass is somewhere here, here, on this line. But how to find the exact point at which we can consider all the mass is concentrated there? We have a practical method I can show you. First of all, let's learn about the plumb line. This is a very traditional way to make sure that the wall the construction workers are making is 100% perpendicular to the surface of the Earth. This is just a single very simple pendulum. Here we have the center of mass of the bob at this point, the hanging point, and the center of the earth. They are always set on a line, you know. And because of that, the line that the plumb line is guiding will tell the construction worker how to make the wall parallel to that to be 100% perpendicular to the surface of the earth. Okay. Center of mass of an asymmetrical object. For every arbitrary object, there is a very simple way to find the center of mass. It's very easy. Hang the object from every arbitrary point, every corner you want, okay? And then you can also hang a plumb line. This plumb line will tell you that this is the line, the guiding line, on which you can find the center of mass. Center of mass might be at a point like this, on this line. But how to find that exactly that point? Draw a line on the object. Okay, draw a line using a marker, and then hang the object from another corner, another arbitrary corner. Then again hang the plumb line and draw another line. The center of mass must be the intercept of these two lines. It's very easy because it must be on this line and also must be on this line. So is the only chance is here. This is the center of mass. It's for a symmetrical object and also symmetrical object. For symmetrical objects, we have some easier geometrical methods using integration. You can cut a rectangle or a triangle from a piece of metal or cardboard, whatever, and then find the center of that shape. The center of that shape will be the center of mass, okay? For the triangle, according to geometry, we know that the center of triangle is at the point separated for a third of the height from the base. We don't want to go over the integration methods of that in high school level. About the solid hemisphere, the center of mass is somewhere here, separated for 3r over 8 from the base. R is the radius. And for a solid circular cone, the point is in a quarter of height to the base. Okay. There is another lesson you should learn before we finish this episode: translational acceleration. Look at this bat. This is a baseball bat, okay? And let's say the center of mass is here, okay? I exert a force exactly at that point. So the line of action of the force is passing through the center of mass, okay? And forget about gravity. Forget about gravity. There is no gravity, okay? Just this is a single force. That single force also could be gravitational force, but forget about it. Let's say this is an external force. You push the bat, okay? The line of the action of the force is passing through the center of mass. There is a very important message behind that. You know the torque is zero, the torque due to the force on the object. The reason, center of mass will be the center of rotation of the object, okay? And as the force is passing through that point, there is no distance between the force and the center of rotation. So there is no torque. No torque means that there is no rotational acceleration, no angular acceleration. Alpha is zero. You should have just a chance of acceleration, linear acceleration for the object. So if the force, a single force, is passing through the center of mass of the object, it cannot make any angular acceleration, just translational acceleration. And this acceleration is found out of F divided by m, according to the Newton's second law. Then let's have a couple acting on the system. Couple means a couple of forces that are separated for a distance d, okay? They are equal and opposite forces. You know the F net force on the object is zero because these two forces will cancel each other, okay? So acceleration, linear acceleration is zero. But you know that the couple will make a torque, okay? And we learned it in previous lessons. So we have a chance of angular acceleration. So we have angular acceleration but no linear acceleration. The last is when you apply a force acting on the object, single force, but not passing through the center of mass. This force is separated for a distance d to the center of rotation, so it can make torque, and therefore we will have angular acceleration. And more than that, net force acting on the system is not zero, so we have net force, so net force will create linear acceleration also. This is why we say concept of center of mass is very important. Let me summarize it. For an object, if the force is acting on the center of mass, acceleration is not zero, but angular acceleration is zero. When the force is acting on the object not passing through the center of mass, this is center of mass, here we have both linear acceleration and also angular acceleration. When a couple is acting on the object, necessarily this couple includes a couple of opposite and equal forces, okay? They cancel each other. There is no translational acceleration, but we do have angular acceleration due to the torque created by this couple. Thank you for attention to this lesson. Have a review and let's go to the next one.